Howdy, it's Mr. Russell introducing you to chemical names and formulas with oxidation states. Now, when I say the oxidation state, I'm meaning the charge of the ion. We're specifically talking about the ions involved in ionic bonding. So the reason why I'm not saying charge all the time is because oxidation state is a good habit to get into and a good habit to call it. Now, when I see the normal periodic table that's in your classroom, yours is blue because it's easy to find, but this one is white. I'm going to cover up the ones that have changing oxidation states. And that's right, I am covering up the transition metals and all of those to the left right here. Okay, so when I do that, I know that every other one of these, every element that's pictured here has a fixed oxidation state. It has a fixed charge. I can find easily what charge it has now, but just by looking at where it is. So I know the noble gases have a charge of 0. And I know the halogens have a charge of -1. If I go to the other side, the group 1 elements have a +1. So now I'll go back to the right side, and these will have a -2 charge. All of these in this group will have a -2 charge. All of these will have a +2 charge. All of these will have a -3 charge, nitrogen, phosphorus, and arsenic. And these will have a +3 charge, boron and aluminum. And now carbon and silicone are right in the middle. They don't bond ionically very much, actually ever at all. So we'll just exclude those, and I'll put my pen right here in the middle. Notice this is almost like a football field, where if you have a 50-yard line and you have the 40-yard line on 40 yard lines on the either side, and then the 30, and then the 20, and the 10, and the goal line. So this is similar. This is called a palindrome. It's how the periodic table is set up. So now these oxidation states for the transition metals can be a little funky, where some of them will, like iron, can have a +2 and a +3, depending on what it's bonded with and where it is and what chemical properties it has. So these, and some of these, like vanadium, can have 5 oxidation states. So that's why we save these for reference, and we use these nice, beautiful reference sheets that are available for free in my classroom. Now that we've been able to identify what an oxidation state is, could you go back to those previous periodic tables and fill in the oxidation states for all of these? Magnesium's in group 2, so it is a +2. Sulfur's in group 16, so it's a -2. Phosphorus is in a -3. Cesium is a +1, oxygen is a -2, and then aluminum is a +3.